Refrigeration is the process of removing heat energy from a product or substance. A refrigeration system is a machine designed to move heat energy. It does this by transferring heat from the space to be cooled to the atmosphere. To make the vapor compression cycle work, a number of components are required. The major system components in a split system include the compressor, the condenser, the evaporator, and the refrigerant metering device, also known as the RMD. The compressor compresses and circulates the refrigerant around the system. It maintains pressure difference between high and low sides of the system. It compresses low pressure, low temperature vapor to high pressure, high temperature vapor, so it can be condensed by the condenser. Here we can see low pressure refrigerant moving into the compressor from the evaporator. And here we can see high pressure refrigerant moving out of the compressor into the condenser. Both Charles and Boyle's gas laws are observed here in the compressor. The condenser rejects heat to the atmosphere on cooling mode. It removes heat from superheated refrigerant vapor by pulling ambient air over the finned coils from behind the unit to cause the refrigerant to condense to a liquid. This is a latent heat change of vaporization. The ambient air is heated through conduction, which results in warm air being rejected by the condenser. When in cooling mode, the air blowing out of the condenser will always feel warmer than the ambient air temperature. The evaporator is where the heat is absorbed into the refrigeration system. The warm air is pulled into the evaporator and over the coils by a drum fan located in the evaporator, which is then used to blow the now cool air into the room. The refrigerant enters the evaporator in a low pressure liquid state and is vaporized or boiled by absorbing heat from the warm air flowing over the coils in the evaporator. The RMD, or refrigerant metering device, limits the liquid refrigerant into the evaporator by restricting the flow. The RMD reduces the high pressure liquid to a suitable low pressure liquid. By using temperatures measured throughout the system, the electronic expansion valve adjusts the refrigerant flow to maintain a constant pressure temperature in the evaporator. An electronic expansion valve is the most common type of RMD in split systems. Other system components include the discharge line, which connects the compressor to the condenser, the liquid line, which connects the condenser to the RMD, and the suction line, which connects the evaporator to the compressor. The discharge service valve, DSV, is the smaller of the two pipes. In cooling mode, liquid refrigerant leaves the outdoor unit for the indoor unit. The suction service valve, SSV, is the larger of the two pipes. In cooling mode, it sucks the vapor refrigerant into the compressor. In a split system, there is a high pressure side and a low pressure side. The high side of the system is the part of the refrigerant system containing the high pressure refrigerant that is created by the compressor. The refrigerant is at a high pressure in the discharge line, condenser, and liquid line up to the RMD. The low side of the system is the part of the refrigeration system containing the low pressure refrigerant. The refrigerant is at low pressure in the evaporator and the suction line.